Hi everyone, this is another Math 082 video. This is section 4.4 where we learn about difference of squares. So as you can see, there are many problems on this page. What I would recommend you do is to pause this video and to go through and just identify those binomials which are prime. So take a minute and do that, and then unpause the video and see if you have answers that agree with mine. Okay, here we go. So this is prime because we are adding instead of subtracting. This is also prime. This is prime because we're adding instead of subtracting. And this is prime because we're adding instead of subtracting. This is also prime because we're adding and not subtracting. And I'm going to put a question mark here and come back to that. We'll come back to that in a minute. So for all of the ones that I did not mark prime, we need to then go through and practice applying the difference of squares. So again, I would suggest pausing this video and doing that on your own, and then unpausing the video and seeing if my answers agree with yours. Okay, I'm about to start writing the answers. So for this one, this is a difference of squares. It's a plus b times a minus b. Okay. For this one, well, we have a subtraction sign, but 35 is not a perfect square, and y to the 7th is not a perfect square, so this one, therefore, must be prime as well. Okay, over here, we do have a difference of two perfect squares, so we have 6 minus y times 6 plus y, or, of course, you could write it the other way. It doesn't matter what order you put it in. Over here, you can see that 2 and 50, neither one, are perfect squares. But remember, our first step is always to look for our GCF, which in this case is 2. So then we get 2 times x squared minus 25. So we get 2 times the quantity x minus 5 times x plus 5. And that would be our final answer. This one's pretty straightforward. This is x plus 5 times x minus 5. Okay. The reason I didn't mark this as prime is, as you might have noticed, this is a 2 and this is an 18. They're both even numbers, so I can factor out the 2. Now, of course, I can't go any further because x squared plus 9 is a sum of squares, not a difference of squares. However, I wouldn't say that this polynomial is prime because I was able to factor it in some way. Let's do the last one. Again, I can factor out the 2, and that leaves us this time with a difference of squares. So we have 2 times the quantity x plus 3 times x minus 3. And that's it. So take note and see how you did. See how your results compare with those from this video.